In this video, we are doing another limits and continuity question from a previous question paper. This question was taken from August 2024, and as you can see, the entire question was worth 6 marks. Before we can attempt the question, we need to figure out the indeterminate form of the limit. Okay, and I've gone through all the 4 different cases, and you can click in the link in the corner to find out more on what to do in each different case, because I went in more detail. If you're new to my channel, please don't leave without subscribing, don't leave without liking, sharing, and commenting, as I post BSc, BSS, and Maths videos from N5 all the way to N6. I'm not going to do a lot of talking. Let's just get into the video, right? So we need to figure out what happens if we substitute 0 over here and if we substitute 0 over there. Okay, and then that is how we identify the indeterminate form, and then on the denominator we do the same thing. But as we can see already in the denominator, we're going to have 0, because if you substitute 0 over here, the denominator will be 0. And then if you say tan 0, your answer is also 0, and then sine 0, the answer is 0. So the indeterminate form of ln y is equal to, ln y ln x approaches 0 tan x minus sine x over 3x squared. So this is the indeterminate form, it's 0 over 0. So what do we need to do is to apply L'Hopital's rule. What does it say? It says that we should find the derivative of the numerator in the denominator and try substituting. Maybe we will get a numerical value. Okay, because that is what they want. Actually, they want us to find the numerical value of this expression. So the derivative of 10 is going to be sec squared x. But guys, sec squared x is the same as saying sec x and squaring it, right? I write it like this because when you're deriving, we might have to derive the second time, so you drop the 2 there. Okay, so let me write it this way: minus the derivative of sine. The derivative of sine is cos, so say minus cos x. We will divide this by the derivative, which would be 6x, right? And if we substitute 0, if we substitute the denominator, you can see that the denominator is also going to be 0, right? So the indeterminate form of this one, the denominator will be 0, the numerator will also be 0, because cos sec is the reciprocal of cos, so it's going to be 1 minus 1. This is going to be 1 and this is going to be minus 1. Eventually the top will also be equal to 0, so we need to derive again. So we'll say lim x approaches 0. Okay, and then we need to drop, right? So we'll say 2 sec x times, now the derivative of sec is sec 10, right? Because you have to derive that, you have to derive the whole function, and then also derive this expression. You guys should know this, right? Derive this expression and then also derive whatever that is inside the bracket. Okay, so we will have to say sec x times tan x. This is the derivative of sec, by the way. Okay, and then we'll say minus the derivative of cos is minus 10. The derivative of cos is minus sine. So minus is going to be positive. Okay, so we'll say plus, sine x, and we will divide this by the derivative of 6x, which is going to be 6. Okay, now let's try to substitute and find out what happens. So lim x approaches 0. What happens now is that we can actually find out what is this sine. The derivative sine 0 is going to be 0, so we just take that one out. Okay, so let me just take that one out. So our answer is going to be over 6, but now we need to find out what is the derivative. What happens when you substitute 0 in here and then 0 there and 0 there. Okay, and if you punch that right into your calculator, you should find out that the whole numerator is equal to 0, so it'll be 0 over 6. And then we know that 0 over 6 is the same as saying 0. Okay, so that is the numerical value of learn y. Learn y is equal to 0. Now we need to find out the value of y. Okay, we now need to find out what is the value of y. So you need to know how you use your log. So let me just erase this. This one is important because we need to know how to use your log. Okay. Okay, so if learn y is equal to 0, then when we introduce log, that means that log base e, remember, learn y is the same as saying log with base e. So it's log base e. Okay, let me just write that properly. Okay, y is equal to 0. So therefore, y would be equal to e to the power of 0. Okay, pardon my writing, like that, to the power of 0, which will just tell you that y is equal to 1. Okay, that's why it's 1 mark. All right, the following question wants us to find out the value of x for which this function is discontinuous. The values of x for which this function is discontinuous, guys. If a function has to be discontinuous, the denominator will have to be equal to 0. So we'll say sine, okay, we'll have to say sine x is equal to 0, and then find out the reference angle, which is sine, which is x. So x is also going to be equal to 0. How do you know this? Well, you'll just say shift sine, shift sine, and then it will give you that sine to the -1 thing, right? X is your reference angle and it's equal to 0. So you need to find out the quadrants where sine x is positive. It's positive in the first quadrant and in the second quadrant. So what happens in the first quadrant? Well, x is equal to 0. Actually, not 0. X is equal to 90 minus 0 degrees, right? Exactly, because here you have 90 minus 0. Okay, so x is equal to 90 minus 0 degrees. So x is just 90 degrees in the first quadrant, 90 degrees. And then in the second quadrant, what do you do in the second quadrant? Let me write it here. You have 180 degrees minus 0, which is also going to be 180. So the end, x is equal to 180 degrees. So these are your two answers. So whenever they ask you to find out for x, to solve for x when you have a trig ratio, just know that your answer will result in a general solution. Guys, thank you so much for watching. Don't leave without subscribing, sharing, commenting, and being part of this community. Until we meet again in the next video, cheers.